let's talk about separable differential equation. So a differential equation is just an equation which has a derivative and it's expressed as something. And it's separable because we'll be able to integrate on both sides and get a solution for y in terms of x or x in terms of y. So let's see what this one is. So this says x over y squared plus 3y is equal to dx by dy. So now, instead of going from y to dy by dx, we're going from dy by dx, and now we want to find y on its own or x on its own. And this is not even dy by dx, this is dx by dy. So let's change this around, and we'll come to these y is equal to 3, x equal to 1 later. So let's do 1 over everything on both sides. So if you just swap the numerator and denominator around, we'll have y squared plus 3y divided by x is equal to dy by dx. Okay. Now, imagine you were treating dy and dx this as a fraction as well, okay? So you can bring the dx to the other side, so you would have y squared plus 3y divided by x times dx is equal to dy. And now let's say you bring the y squared plus 3y to the other side, so you would divide by y squared plus 3y on both sides. So you would have dx divided by x is equal to dy divided by y squared plus 3y. And now you can see we have dy and we have everything in terms of y on one side, and we have dx and everything in terms of x on the other side. So this is why it's separable, because you can separate x and y and then you can integrate on both sides. So let's start integrating. So if we integrate over here and we integrate over here, what do we get? Well, over here we can integrate first dx over x. So that's just the integral of 1 over x, which is ln x plus c, of course. And then here we have the integral of 1 over, and then let's factorize this. So you have y, and then you have y plus 3 dy. So how would you integrate this? So let's use partial fractions to write this in a better way. So you have, let's say you had a over y plus b over y plus 3 is equal to 1 over y plus 3. And now we need to find a and b. So how do we do that? Well, we can multiply both sides by y and y plus 3. So you have a, and when you multiply by y, this cancels out, but you're left with y plus 3. So you have a y plus 3 plus b, and now the y plus 3 cancels out, and you're left with the y. So you have by is equal to, and then everything cancels out, so you're left with 1. Okay, so far so good. Now, when y is equal to 0, then we have 0 plus 3, so that's 3. So that's 3a plus 0b is equal to 1. So you have that. That means our a is equal to 1 over 3. And then when y is equal to negative 3, then you have negative 3 plus 3 is 0, so that's gone. And then you have negative 3b is equal to 1. So you have our b is equal to negative 1 over 3. Okay, so that means we're gonna be integrating. This is the same as, so you have 1 over x, you have ln x plus c is equal to the integral of, and now we have a over y plus b over y plus 3. So a is 1 over 3 and b is negative 1 over 3. So let's bring the 1 over 3 outside. So you have 1 over 3, and then you have 1 over y, because our a is 1 over 3, so you have 1 over y, and then minus 1 over y plus 3. So minus 1 over y plus 3 dy. And we brought the 1 over 3 outside. Well, now this is easy. These are just two separate integrals to do, and these are just in terms of natural log on both sides. So we have the natural log of x plus c is equal to 1 over 3, and then we have the natural log of y minus the natural log of y plus 3. And then we have another constant here, right? So let's call that constant k, for example, plus k. Okay, now what do we do? Okay, we have ln a minus ln b, so we can do ln a divided by b, and then you have 1 over 3 there. So you have ln x. And now what do we do with the constants? Well, you have a constant here and you have a constant here. So even if let's say you bring this k to the other side, right? You have c minus k. Well, that's just another constant, right? So let's call that constant, let's call it m, for example, right? Let's call it m. That's our other constant. That's equal to c minus k, and that is equal to 1 over 3, and then you have the natural log of y divided by y plus 3. So far so good. Now is when we need to find m, and now we use these initial conditions. We had y is equal to 3 and x is equal to 1. That means when x is equal to 1, so that's ln 1 plus m is equal to, you have 1 over 3, and then you have ln, and now y is equal to 3, so you have ln of 3 divided by 3 plus 3, which is equal to 6. Okay, we have ln 1 plus m is equal to 1 over 3 ln 3 over 6. So that means m is equal to, well, 1 over 3 ln 3 over 6 is just ln a half, which is negative ln 2. So we have negative ln 2 divided by 3. Okay, so far so good. Now we put m back in here. So we have ln x minus ln 2 over 3 is equal to 1 over 3 natural log of y over y plus 3. And let's say you want to make this more clean, so we multiply by 3 on both sides. So we would have 3 times natural log of x, which is ln x cubed, minus natural log of 2 is equal to the natural log of y over y plus 3. Okay, let's see, we want to find y on its own. So now ln x cubed minus ln 2, that's again ln a minus ln b. So you can just, let's do it on this side. So that's ln of x cubed over 2 is equal to the natural log of y over y plus 3. Okay, we're very close to getting y on its own. Now, this is natural log on both sides, so we can just get rid of that. So we have x cubed over 2 is equal to y over y plus 3. Okay, multiply by 2, so you have x cubed is equal to 2y over y plus 3. And then bring the y to the other side, so you have x cubed times y plus 3x cubed is equal to 2y. Bring this 2y to the other side, so we have y x cubed minus 2 is equal to minus 3x cubed. And now you have y is equal to minus 3x cubed divided by x cubed minus 2. So that is our y in terms of x. Let's see if our initial conditions worked. So when we said when y is equal to 3, x is equal to 1. So when x is equal to 1, we would have negative 3 divided by 1 minus 2, which is negative 1. So negative 3 divided by negative 1, which is positive 3. And that is what we said y was. So now let me ask you a question. Let's say you didn't know any of this, and the question was, what happens when x goes towards infinity? So that means it's going towards infinity. That means, what is y equal to when that happens? So now let's look at what we have over here. So in order to solve this equation, let's say I had this given to you at the start, and you're just given this, and you're given the initial conditions. You will not know how to solve it yet, because you don't know what y is in terms of x. But now you've got y in terms of x, and it looks like this. And when x is going towards infinity, okay, so you'd have negative 3 times a very big number, divided by that very big number, and then minus 2. Well, we don't really care about the minus 2, because as you get bigger and bigger, this number gets so big that minus 2 becomes irrelevant. So we can just get rid of it. So you have y is equal to negative 3x cubed divided by x cubed. We just got rid of the minus 2. And then as x is going towards infinity, well, it doesn't matter, because then our x cubes cancel out. And you're left with y is equal to minus 3. And that is actually our answer for when x is going towards infinity. So I'll put a graph up on the left side. And that means that our y is going towards minus 3 as x is going towards infinity. And you will see what that looks like on the curve. You can draw this curve by yourself as well, and you will see that this is true. So yeah, that's separable differential equations. Hope that made sense. If it did, please like, share, comment, subscribe, and let me know what else you want to see in future videos.